Assalamualaikum everyone, welcome to another video of CSA320 Data Communications, and today we'll be discussing about transport layer and we'll go through it very quickly. We have a brief discussion because we have lots of things to discuss. And now let's see. So the part of the OSI and TCP IP, transport layer has its different place. The protocols used here are TCP and UDP. We also have SCTP, but we'll be discussing about TCP and UDP only. And the PDU in it is segment. Okay. Moving on. A little about network layer and transport layer. Network layer is a logical communication between hosts, where transport layer is actually the logical communication between processes. And if you want to explain transport layer in one line, then it would be just one process to another, transferring one process to another. Transfer is the key word. Primary functions. Okay, let's get to work over here. You have segmenting and reassembling. So you convert it to segments when you're sending, and you reassemble the segments when you're receiving. Multiplexing segments from two different places, different devices. Identifying and tracking the segments of different applications. It's not necessary that only your Mozilla Firefox is using the transport layer. There's Opera, there's Internet Explorer, even though it doesn't matter because it will take all day, and there's Google Chrome. So different applications have different work with the transport layer. So all of them, go flying guy, all of them will have their own spaces. Do not underestimate Microsoft Edge though, it's good. So establishing a connection before data transfer, error control, flow control. Flow control is the idea that keep a track of the data. Don't just send all of them. Make sure that he is able to receive it and there's enough traffic. That's the idea of flow control, and you already know what error control is. So let's move on. Now you have segmenting data, which is one of its work, and a little image of all the works for you to see. Okay, now that we know the responsibilities, the protocol should be able to do all of these tasks. That is how I will be able to do the work of transport layer perfectly. I need all these functions to work properly. So the protocol that gives me all of this function is the winner. So who is that? Who is that one who will give me reliability? For example, why do I need that? Let's see. Where is my pencil? In case of email and HTTP, data needs to be complete with no errors and gaps. If you mess up, if there's email over here, if there are errors over here, a very important email could be skipped. A very important email, I may not receive it. Emails are serious issues, and HTTP also. I need to keep my website secure and do the data transfers properly. Not to mention, slight delay is acceptable to ensure this, but a good delay is not acceptable because you need everything on time. If I send you an email today and it goes to you after 2 days, that could cause a problem. On the other hand, look at this. If I have some errors, for example, hello, 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 now I can hear you. Okay, we can accept that. But I cannot accept hello. And 2 days later, so you have your best friend and you call him or call her and say hello, and 2 days later they reply hello. Delay is not acceptable in this case. But okay, if you're like hello, 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 and your best friend says hello, how are you? Let's play PUBG or something, So this is acceptable, but this is not. In this case, error is not acceptable. However, a little delay can be considered. So you can see that functions in different cases are different. Now, why are we discussing this? Because we will be talking about layers. This is the idea. The TCP protocol is actually reliable, which is perfect for use in SMTP, HTTP, stuff like that. So it will not have errors. However, it may have delays. As for IP telephony or streaming videos, it will not have delays. It will be fast, but it will not be reliable, so you may face errors a lot. So 2 protocols, 2 users. That's why we discussed this. Let's fast forward. Now this is a header, the structure of a transport layer header. Look at this. We'll be discussing about TCP headers, and we'll also be discussing about UDP headers. So for the TCP header, let me show you. We have a lot of ports. For source, 16 on source, 16 over here, so 32. 32 over here, 32 again, sequence number, acknowledgement number, 32 again, 4, 6, 4 for header length, 5, 6 reserved, 10, and then 16, and 16 for Windows, that means 32 again. Checksum 16 and urgent 16, 32 again, and options, which is optional, 32. So 64, 128 and 192. No, wait, 128 plus 36, how much it is? Okay, math time. 128 plus 32, that is actually 50. Okay, and then there's again 32, 64, so you can, that's optional though. So this is the structure, which is 20 bytes, and the bit, I gave you the bit tree over here. That's for TCP. Now there's another one, UDP, which is only 8 bytes. So you can understand a very good reason why it would be fast, because it's much smaller than this. So you only have the source, destination port, checksum over here, and length. That's all. Nothing more, nothing less. Okay, now that we know the headers, let's see in details. Okay, there are some things to discuss over here. So source destination is same for both. Sequence and acknowledgement, we'll talk about this. This is the header length. This is reserved, which are not necessary right now. This URG stands for urgent. This is for acknowledgement. This is for push. This is for reset. This is for synchronization, and this is for finishing. These are flags. These 6 are flags. We'll talk about them. Window size, urgent pointers, and checksum. Checksum is also here as well, and total length. That's all. Okay, port numbers. Now this is an important part of transport layer, so we're dealing with port numbers. So application port could be 110. For HTML pages it is 80, and then you have internet chat, which is 531. So port numbers are fixed, and port numbers are handled in this way. This is important for your MCQ or multiple choice question. 0 to 1, 2, 3, these are famous ones, well known ports. 80 is an example of that. 1024 to 4951, these are registered ports. Those are registered by big companies and for other purposes. However, this part it could be private, it could be dynamic. So this is actually the part which we use. This port is something that we use. Okay, so you can see, oh, that's nice. This is not rest in peace. Anyway, FTP data 20, FTP control 21, 23, telnet, SMTP, POP3, you have all these port numbers which are well known. MSN Messenger is not an internet, it's not well known, but it is a private company, so they use this. And alternate HTTP 8080, this is something we are using right now. SIP, RTP, these are examples. Okay, so we are done with this. Look at this. So the source port address and the destination address right here. See? So these port addresses are important. Okay, we're not getting to the good part yet. Okay, what if there are two sessions in the same server? For example, from 50 it is also trying to get to 80, and there is 4955 who's also trying to get to 8080. What now? But we can have things that keep sessions unique, right? So that's your solution. Okay, not this even. Now we'll talk a little bit about this. So, sequence number, acknowledgement number, and these flags. These are our main points of discussion today. Like I told you, urgent is for urgent, acknowledgement, this is acknowledgement, this is push, this is reset, this is synchronization, and this is finishing. To terminate the connection, you use this. To synchronize sequence number, you use this. To reset the connection, you use this. To push means request. Acknowledgement means, okay, I am accepting this. Urgent will stand for if it is urgent. VIP. 6 bits. 0 stands for on, 1 stands for off. So if this is working, it will be 1, and if it's not working, then it will be 0. We'll get to know this. Okay, now. Okay guys, we're down to the real part over here. A very crucial part of TCP that we're going to discuss right now is this. Okay, so you have this client and you have this server. They're about to start data transfer, and transport layer is about to do its work. So I have this TCP header with the source port nong, destination port number, sequence nong, acknowledgement number. 49152 is my source port number. 80 is my destination port number. Okay, so here I put the source port number, and here I will put the destination port number. As you can see the structure above. Sequence number is 0 because I haven't sent anything yet. Acknowledgement number is 0 also because I am not receiving anything yet. Okay, now I'm starting synchronization. Here's my file. I have sent the file. Okay, now we are at the server. For the server, the source port is 80 and destination is 49152. He hasn't sent anything yet, so its sequence number is 0. However, he is expecting for 1 to come. This is an important part over here. That's why we have this acknowledgement over here, you see, which was 0 in case of him because he was not expecting, he was about to send. But the server is expecting, so he has this acknowledgement number 1. He also has synchronization on. but he also has an acknowledgement on. So it's 1 and 1 on acknowledgement and synchronization, and the rest is 0. Now he has the response and he sends the response. We are back to the client. The client has its source as 49152 and its the destination as 80. Now the sequence number is 1 because he's about to send, and he's been expecting 1 as well. So he also has an acknowledgement, and then he sends the file, which is 1, and for the client server side they will receive it in the same way. Let's have another look. Let the sequence be 100, okay, and the flag I am turning on now is synchronization. Okay, so it receives the SYN, and then it sends acknowledgement and SIG 300. Acknowledgement is 101 because 100 was sent, so the next time I will receive 101, and I am sending 300. That means my acknowledgement would be 300. See, so my acknowledgement is 301 because I have already received 300. Here my acknowledgement was 300 when I received this. Now my acknowledgement has changed, and the sequence. And to terminate any connection, first the fin is sent by the host A, and he receives the finish flag, and then sends acknowledgement, he receives the acknowledgement, and that's how you terminate this. Error control, this is the best part of TCP. They are able to control the error. So there's something to note over here. You have this, start with 1 byte, and I'm sending 10 bytes. The client lets the server know. The server says, okay, I received 10 bytes, and it starts with 1. So next time, if you have sent 1 to 10, then I'm expecting 11. And then this will be sent over here, and then he will say, I received 10. Since you're expecting 11, I'm sending 11. That's how this works. And this is why the acknowledgement over here is 11, because he's received 10 and now he's waiting for 11. You see? After the 10 bytes is sent, this is how the acknowledgement changes. Okay, now we are going to show you through bytes. Okay, so you already know these positions, and we're about to push, and we're going to send up to 0 to 399. That means we're sending 400 bytes. Now let's send it. Okay, now we are talking from the server side. Okay, I have a sequence number 1, and I am acknowledging 400. Why? Because 0 to 399 was sent. So the next byte is my acknowledgement number here, 400. By the way, I'm sending 1 to 600 to you. Now guys, before I move the slideshow, can you have a wild guess what would be the acknowledgement number for client? 601. See? Ta-da! It's such like that. 601. And the sequence number I sent is starting from 400 because I have already sent 0 to 399, so that's why the sequence number has changed. Okay, I didn't send any bytes now, it's 0. Okay, sequence 801. Okay, and acknowledgement 15001. That is something I will receive. After I sent 8001, I'm sending 9001. So I sent 9001, and the acknowledgement is 10001 because I have sent up to 10, so he would wait for 10001, and I'm waiting for 15001, so he's sending that, which is the sequence number. The thing I'm acknowledging here is the sequence over here, and the thing I'm sequencing here is the acknowledgement over here. The end is being acknowledged over here. Okay, so this is how this works. We'll see even more examples. Here, let's see this. I'm about to send 200 bytes to you, which is up to 1400. That means my acknowledgement would change to 1401 because I have already received this. I'm talking as the server. I'm going to send myself 1000 data to you, 1000 bytes. So make sure to receive that. You're going to send 1000. I don't care how many you send, how many types you send. Just let me know what's the end bit you're sending. Okay, it's 5000. Okay, then I'm expecting 5001 after I receive that. He received this. Once it is received, the acknowledgement has changed to 501, which was 401 over here, 4001, because he did not receive this yet. After receiving this, the acknowledgement changed. So the sequence number, after receiving this also, the sequence number will change too. So I'm sending 5000 to 6000, 6000 to 7000, but my acknowledgement is not changing. It is still 1401. Why? Because I have not received anything since 1400 was sent. I did not receive anything since that. So after that, this remains unchanged. So it's not necessary that always there should be give and take. It could be only giving, it could be taking, and it could be giving and taking. Okay, now what if there's an error? Let's see this. This is cool. So you have 500 to 600, you're sending 600 to 700, and then after receiving 700, the expectation is 701, and he sends 701, but your mom said, come on, turn off the computer right now, and the computer is shut down, and he sent 700 but you didn't receive it. And as your mom leaves the room, you turn on your computer, but he doesn't know that you didn't receive it, so he sends 800, but your PC turns on and he says, hey, he's receiving 801. Okay, I keep it over here, no problem, but my acknowledgement number will not change because I still didn't receive this. You didn't receive this? Okay, I'm sending it back. And then you send 701 again and the gap is fulfilled. You see? And then the rest. Okay. See? That's how it works. This is how you control error. Same thing over here. Flow control. Okay. TCP windowing. With a window size of 10, each segment carried by is only 10 bytes of data, and you must be acknowledged before the segment is transmitted. So the window size matters over here. Let's see if I find something important. Okay, now we are on to UDP. There are some primary problems. You don't get fast for nothing, you know. You need to give up something. No reassembly, no error checking, and no flow control. This is the ultimate failure. But this is also connectionless, by the way. So this could be your advantages, and it could be a big disadvantage. For streaming, phone calls, stuff like that, it is a great advantage. At the same time, for anything else, it is a great disadvantage. Okay, so let's move. This is the part of discussion. TCP features, UDP. So you have different tasks and different protocols are perfect for different functions. For a primary view of the differences, here it is. Connectionless, it has connection. Segments and error control is good, no error control. So sort segments, forget sorting. No sorting, come on, I'll just receive and send, no sorting. good speed control, flow control, no flow control, just keep on sending. High overhead, only 20 bytes, no, 20 bytes. By the way, I have only 8 bytes, so I'm faster. Emails, web browsing, where you cannot tolerate errors. Phone, video streaming, DNS, where you cannot tolerate delays. That's how you use them. And that's the end. Thank you for watching. I hope it was good, and see you until the next video.